Good morning, honorable moderators, reviewers, and everyone in the audience. Allow me to introduce our team from the School of Computer Science at Bina Nusantara University. My name is Adam dari Ilham.
My name is Hiskia Mozes Palenteng.
My name is Aribawa Mughni Hidayah.
Today, we will present our research title Capability, Safety, and Security Benchmark for Computer Use Agents, a systematic review. In short, our study asks how we should evaluate AI agents that do not just answer, but actually take action. Let me begin. To give you an overview, this presentation has 6 parts. We start with the background and motivation, then our 3 research questions and their objectives. After that, we explain the method we use, followed by our results, a discussion of the framework we propose, and finally, our conclusions. Let us begin with the motivation. For a long time, we have been used to AI like chatbots that only answer through text. But now a new kind has emerged, called Computer Use Agents, or CUAs. The difference is that these agents do not just answer, they actually act. They can click, scroll, type, open files, and even change several tools together across browsers, graphical interface, and operating systems. As a simple illustration, imagine an assistant that does not just tell you how to book a ticket, but actually opens the website, fills in the form, selects your seat, and clicks the pay button for you. That is roughly what a computer use agent does. And here is where the problem lies. If a chatbot makes a mistake, the damage stops at the level of text. But if an agent that can take action makes a mistake, the consequences are real. It can modify files, send messages, or open malicious pages. And all of this can happen with no human in the loop. Threats such as prompt injection, visual manipulation, and privacy leakage are already documented across many studies. There is a second problem. This research area is fractured into 3 parallel tracks: capability, security, and safety. Unfortunately, these 3 rarely meet, which means the way we evaluate agents stays incomplete. Okay, so for the next, let me, my friend, explain to you all.
Okay, so for the next slide, I'm going to read for the slide 4, research questions. Building on these problems, we formulated 3 research questions. The first is about conceptualization. How are the safety, security, and evaluation benchmarks for COS defined and measured across recent literature? The second is about the threat landscape. Which threat categories recur and how are they distributed across platforms from web, GUI, and browser to operating system and mobile? And the third is about methodological gaps. What gaps prevent today's benchmarks from assessing agents in a holistic and realistic way within one shared framework? So the next slide, research objective. We translated these 3 questions into the 3 concert objectives. First, to map and classify how recent studies define and measure an agent's capability, safety, and security. Second, to identify the recurring threats and chart how they spread across platforms. And third, to expose those gaps and propose a 3 tiers framework, namely environment threat model and evaluation protocol. All 3 converge on one outcome: a coordinated evaluation framework for the field. So, research methodology. To answer these questions, we use a systematic review following the PRISMA 2020 standard. In short, PRISMA is a standard guideline that keeps our search and screening process transparent and repeatable by other researchers. Through this process, we analyzed 30 studies. Our source came from 5 databases: Scopus, IEE Explore, Science Direct, Taylor, and Francis, and a curated set from Archive. The time window was 2023 to 2026 in English only. The scope covers studies that evaluate, attack, or benchmark agents in web, GUI, OS, mobile, or multi-environment settings. For the analysis, we use inductive thematic coding, which means we let the themes emerge from the data itself, and then we check the structure using VOS Viewer. One important note: our synthesis is thematic, not meta-analytic, because the metrics across studies are simply not directly comparable yet. The next slide. What the 30 studies look like. Now we move to the results. This slide gives a general picture of those 30 studies. They are spread across 5 types of environment: web, browser, GUI, OS, and mobile. The most common type of study is the benchmark, followed by attack studies, system studies, safety, and service. What is interesting is that the publication by year chart shows a sharp spike in 2025, which tracks the commercial release cycle of agent products. In other words, the field looks very active conceptually, but as we will show next, it remains methodologically unsettled. The number of products is growing faster than the maturity of how we test them, and that gap is exactly what our research highlights. So for the next slide, my friend will reading the slide.
Yeah, we start with the research question number 1, 5 distinct evaluation tradition. This slide answer our first question. Across the 30 study we found distinct evaluation tradition. It's almost like its own separate lineage. The first is end-to-end capability, which essentially asks did it finish the task, is measured test success, step efficiency, latency, and cost. The second is safety and compliance, which asks did it reviews what it should reviews. The third is UI and understanding, the UI grounding, which asks did the agent see the screen correctly? That is, this ability to locate a button or an element on screen. The fourth one is integrative trustworthiness, which tries to judge how trustworthy the agent is overall. The last one, security and robustness, which asks can it resist manipulation such as decisive pop-ups or prompt injection. The key here is that safety and security life is separate. Traditions use with separate metrics and they almost never appear in the same benchmark. To the next slide is research question number 2, 5 threats that recur. Our second question is about threats, and we found 5 threats that recur again and again. First, indirect prompt injection, where malicious content the agent retrieved from the internet can override the user's original intent. Second, visual manipulation, through pop-ups, fine print, or injected image that mislead agent perception. The third one, privacy leakage, where sensitive data is exposed while the agent browses or feels informed. Fourth, protocol and tool chain exploit, where are weaknesses in how tools are integrated. And last one, unsafe execution, where the agent actually carries out harmful inflation action. The big pattern behind all 5 is this. Most studies are busy proving that attack work. But for we will test wherever the defense actually hold. Okay. Next slide is research question number 3. What prevent holistic benchmarking? Our third question asks, what prevent holistic evaluation? We found 4 gaps. First one, the resolution problem. Because testing is run in sandboxes that are far simpler than real deployment. Second, the measurement problem. Because each study uses its own definition and scale, so the results are hard to compare. Third one, the offense-defense imbalance. And last one, most important one, the integration gap. It has capability, safety, security, and privacy are almost never tested in single pipeline. So an agent reliability is never truly proven. This finding is reinforced by previous viewer, which shows the ritual really does split into separate clusters with very links between them. So this experiment is structural, not incidental. Next slide is discussion and three-tier evaluation framework. From all of this finding comes our main contribution. A tier 3 evaluation framework, the idea is simple. Every benchmark can be placed according to 3 things it actually tests. The first one is the environment. Where does the agent operate, whether web, browser, GUI, OS, mobile, or multi-environment, because the risk profile differs sharply among them. The second one is threat model. Which condition is being tested, wherever injection, visual manipulation, privacy, and so on. So that any claim that an agent is safe always state the definite threat. The third one is evaluation protocol, which is metric applied so that results from different studies can be compared fairly. The benefits are really different for 3 groups. Researchers can test capability, safety, and security at the same time. Developers no longer rely on single-axis benchmark when they move to development. And regulators can address across environment and protocol layer risk. The point is, once we play a benchmark with these three tiers, the empty slot the thing never tests become visibly and immediately. For example, if a benchmark only tests capability in a web environment with no attack scenario at all, then the column for security stay empty, and that gap become obvious in the framework, so it can be acted upon. Okay, for the next slide, will be read by my friend again.
Okay, to conclude this presentation, this review synthesized 30 studies on the evaluation, safety, and security of computer use agents published between 2023 and 2026. One pattern stands out. The field is conceptually active, but methodologically uneven. To put it briefly, there are 5 separate evaluation traditions, 5 recurring threats, and the center gaps are methodological, not conceptual. The solution we offer is that 3-tier framework, which makes the empty slots in evaluation visible. In other words, whether agents can act at all is largely answered, but whether they can act competently, safely, and securely. This is what remains open. Our hope is that this framework becomes a first step toward a shared evaluation standard, so that the rapid progress of agents is matched by the assurance that they are truly safe to use. Okay, that brings us to the end of our presentation. So thank you for your attention. We will be glad to open the floor for your questions and discussions. You can email me or my friend Hiskia or my friend Aribawa. So thank you for watching our presentation today. So hope we meet again. Thank you.
Thank you.